If you're a developer, you know the deal, right? The learning never ever stops. There's always a new framework, a new library, a new paradigm shift to wrap your head around. Well, today, we're looking at what's maybe the biggest shift of them all, quantum computing, and why it absolutely needs to be on your radar.
I mean, come on, who hasn't been there? This quote pretty much sums up the modern developer experience in a nutshell. We live in this cycle of perpetual learning, piecing everything together from docs, blogs, and those lifesaver 10-minute YouTube videos that finally make it all click.
I'm willing to bet you spent more hours than you can count with at least one of these channels. You've mastered JavaScript, you've wrestled with Docker, you've gone deep on Python. The point is, as coders, our real job is being professional learners. We're always adding another tool to the belt. But what happens when the next big thing isn't just another framework? What if it's an entirely new way of thinking about computation itself? Well, that is exactly where quantum computing enters the picture. So, let's dive in. Here's our game plan. We'll cover this new coding frontier, see how it goes beyond classical computers, explore the quantum cloud, meet today's key players, and then map out your quantum journey.
All right, first things first, let's tackle a huge misconception right off the bat. A quantum computer is not just a souped-up version of your laptop. It's a whole different beast. It plays by a completely different set of rules, and it runs a whole new class of algorithms.
So here's the absolute core difference. Your computer thinks in bits. They're like light switches. They're either on or off, a 0 or a 1. Simple. A quantum computer uses qubits. Now, thanks to a wild property called superposition, a qubit can be a 0, a 1, or kind of both at the exact same time. This lets it explore a massive number of possibilities all at once, and that's the secret sauce behind that exponential power scale. But why? Why do we even need this? Well, the brilliant physicist Richard Feynman nailed it way back in 1981. He basically said, look, the world around us at a molecular level is quantum. So if you want to simulate nature to, say, design new drugs or create new materials, you need a computer that speaks nature's native language. And let me be super clear about the power we're talking about here. This is not a 2x speedup. We are talking about a 2 to the power of x speedup. That's an exponential leap. It's the difference between this will take a while and this is literally impossible for any classical computer that will ever be built. So what does all that power get us? It's not for checking your email faster. It's for tackling these absolute monster problems that are just intractable today. Think about designing new medicines molecule by molecule, or solving global shipping logistics in real time. And, there's the big one, potentially breaking the very encryption that keeps the entire digital world secure. Okay, so that's the what and the why. But what about the how? How do you actually get to play with one of these things? Because this isn't science fiction in a lab anymore, this is real. And believe it or not, it's something you, as a developer, can access right now. No, that is not an exaggeration. You can literally run code on a real quantum computer today. The barrier to entry is falling, and it's falling fast, mainly because of the cloud. So you can go ahead and cancel that order for the multi-million-dollar cryogenics lab for your basement. Services like Amazon Braket are basically a gateway to this new world. It's a single platform inside AWS that gives you on-demand access to all sorts of different quantum hardware and simulators, all from an ecosystem you're probably already familiar with. And here's the really amazing part, the sheer diversity of hardware you can use. Through one service, you can run your code on machines built with totally different tech. You have trapped ion computers from IonQ that use lasers to hold individual atoms. And then you have superconducting circuits from Rigetti that run near absolute zero. It's like a buffet of quantum technology, and you can test your algorithms on each one to see what works best. This all leads to a really exciting inflection point. For years, the main use of a quantum computer was, to study quantum computing. We were just studying the hammer. But now, we're finally on the cusp of actually using the hammer to build real things and solve problems in completely different fields. So who's actually building this quantum future? Well, the landscape is just exploding. It's a whole ecosystem of players, all competing and collaborating to push things forward. The race is definitely on, and you can think of it happening on 3 parallel tracks. You've got the established tech giants pouring billions into R&D. Then you have this vibrant scene of nimble startups pioneering really novel approaches. And finally, you have governments all over the world launching national initiatives to try and get an edge. And all the big tech players are placing different bets. IBM is focused on building out a huge fleet of machines with its open-source Qiskit SDK.
Google is all about pushing the raw performance limits with their Sycamore processor. AWS is playing the role of the great unifier, giving you access to everyone's hardware. And then you have Microsoft, playing the long game with a high-risk, high-reward bet on topological qubits.
But it is not just about the giants. Seriously, don't sleep on the startups. They're driving incredible innovation. Companies like IonQ are leaders in trapped ion tech. Others, like Pascal and Quera, are making huge strides with something called neutral atoms. This incredible diversity of approaches is exactly what the whole field needs to thrive. Okay, this is all fascinating. But the big question is, how do you actually get started? Let's bring this all back home and outline a clear, actionable path for any developer who's feeling a little quantum curious.
And here's the good news. Your existing skills are the perfect entry point. Step 1. Start exploring the open-source SDKs like Qiskit or Cirq. If you know Python, they'll feel pretty familiar. Step 2. Use cloud services like Bracket to run your first quantum circuits, first on simulators, then on the real hardware. And finally, Step 3. Dive into the community. It's still early, and it's a great time to learn and contribute.
The time to start exploring this stuff is now. As this quote from AWS's Michael Brett suggests, this isn't a technology where you can afford to just wait and see. The people and the companies that start building skills today will be the ones ready to capitalize when quantum advantage, that point where these machines actually solve useful problems better than classical ones, becomes a reality.
So we'll end with this thought. Classical computers defined the 20th century and created the entire digital world we live in. Quantum computing promises a totally new set of tools to understand and manipulate the very fabric of nature itself. The question for us as builders and developers is, what kind of world are we going to create with it?